So we have a special guest today, Doug Wright. So he's an analyst. So he does like statistics all day long. It just so happens that Doug is also the women's volleyball coach here on campus. So he's a good volleyball player. He's a teacher. And then, hopefully this class is going to expand, and Doug's interested in potentially teaching classes for us. So, like I said, I'm hoping we're going to get through today's information. And then if so, we'll be able to maybe have Doug answer a couple questions as far as like where he sees statistics and what you're doing with this course, relevance in a workplace, and perhaps you guys might have a leg up on versus your peers out in the workplace. So, all right, cool. All right, so we ended up. Were you able to pull that, George?
Yeah.
Okay, perfect. So we wound up going through and basically ripping through our tweets. So just kind of as a recap, we started off with what? We had, let me turn off my emails so that's not bonging all day long. So we started off with 150 tweets that were signal, known good tweets that were going to Mandrill. And then we had 150 tweets that were noise. And what did we do next? Anybody remember? So we took those 150 and we did what?
Clean them up.
We cleaned them up. So we took out some of the periods and the sentence periods, lowercase, exclamation marks, all kind of cool things like that. Then what did we do? We had our clean data, then what? We took that 150 and we drug it all the way down to row 4,500. Anybody remember why we did that? So it sounds like we did 150 and we posted it 30 times. So anybody remember why we had that 30? What was that 30 driven by? So how many characters are in the tweets? 140. So if you take the average words about, I don't know, like 4.5 words, you come up with roughly about 30. So we basically said, hey, these tweets will probably, at most, they'll have 30 words in them. So, we took a conservative approach. It was probably more like, 20 to 25. We're like, let's be ultra conservative and make sure we don't leave any. So we grabbed like 30 words, okay? So we accommodated so we could break it down into 30 words. So once we had all those rows, then we did what? We had to figure out where all the spaces were, right, between each word. And then what do we do from there?
From the spaces, you can mark out individual words.
Yeah, so from those spaces, we were able to take out, little chunks on each word. And anybody remember that process is called? It starts with a T. Tokenizing. Good. Awesome, Alex. Good. So we tokenize that list. And then there from tokenizing, we're able to take all those words, and instead of us trying to count those words up and find the similarities, we did what? We let Excel do the heavy lifting for us. So we basically just threw it into a pivot table, which was pretty sweet, right? Like, wow, that's amazing. You count all those words lickety split, okay? And then once we did that, we said what? We had our words. Then we said, you know what? Let's blow out all the really small words like a, and, the, and things like that. And does anybody remember what those small words are called? Brian, you remember that? Or Anthony? Awesome, Anthony. Good. Those were stop words, right? So those were stop words. And we said sometimes we might have rare words. And if we have a rare word, if we get 0 divided by the total number, that would give us a probability of 0. And if we said, if we have this whole string of words that were strung together through these, by multiplying these probabilities, so we said we could look at this as independence and use joint probabilities, so we could multiply all those words together. We said if we have a 0 in there, it's going to make it into a 0. So we added 1 to all the words so that we could have this whole thing called additive smoothing. So that's kind of where we're at now. So we wound up with, and by taking out the stop words, we came up with our tokens, and we're just added 1 to everything, and that's our additive smoothing step. Okay, so we added 1 to everything. So for additive smoothing. So the next thing we want to do, so we're on slide 19 now. The next thing we want to do is in cell D3, we're going to put that label P token app. So we're just going to do P token. So this is what?
Can somebody say that? How would we say that?
Probability of the token given there's an.
Good. Awesome, Alex. Good. So that we're looking at the probability of the token given that it's the application or the signal, not the noise. Okay? So for us to do that, then we're simply going to take the number of cells we have here, C2, and divide that by the total. And that's going to give us a probability. Now, normally you could click on the cell, and I recommend that. But since this is a pivot table, if you click on C2, you're going to get a big pile of gobbledygook. So just manually type in equals C2 divided by what? It's going to be our total count, and that's going to be what? 2410. But we don't want to hard code this, so we could do what? We can click on the cell. Okay, and we go enter. Now the only problem is what? So the next one we want to have what? We want to have C3 divided by what? By the same total, right? So from a relative reference, if we go down one, C2 will become C3, awesome. But C827 become what? C828. So can we prevent that from going? So we're going to do what? What do you guys think? Maybe put an absolute reference in there. So how do we do that? Anybody remember? Our friend F4. Okay, so if we do that, that puts absolute reference around that. And now you can, and then let's make this, so it says 0, but let's make this into a number. Why didn't mine work? Did everybody else get zeros?
Yeah.
That shouldn't work like that. So equals C2 divided by C827. Oh, it's 0.
Should we decrease the decimal?
Yeah, I should increase it.
Should it be C4?
Oh, thank you. Sorry, thank you, Doug. So we should say C4, right? C4. That's going to work much better for us. Good. Okay, so C4. Okay, and then now we're going to put our absolute reference on there. Okay, now we're going to do what? We could drag all that down if we just double click. Now it's going to autofill all the way down. So that's pretty cool. We did that 4,500 times.
Yeah, I'm still getting 0.
Yeah, so let's see, make sure.
Increase the decimal.
Increase the decimal. There you go. Perfect. All right, cool. Everybody's got it? Okay. Let's see. So you want to do, yeah, you're good. Yep, you're good. And then autofill that guy down. All right, let's see. Yeah, that's fine. If you have an extra decimal place, that's no worries if you have an extra decimal place. Because we said we don't want to multiply all these small numbers together anyways, right? Because we have all these, if we multiply all these little words together, we're going to get like something like 1 times 10 to the minus 45. So what did we say we're going to do? We said you can we said the logarithm of 0.2, we could say the natural log of 0.16 is the natural log of 0.2 plus the natural log of 0.8. So guess what we're going to do here now? We're going to take the natural log of these guys. So over here in this title in E3, just go ln p, the probability. Now you're simply just going to put ln, and then that cell, you can just, for this, now you can click the cell. Okay, then now we have these negative numbers, but they're whole numbers that we'll be able to add up, and it'll make it a lot easier for us to compare instead of having all these small numbers. And once you get that, you're just going to send that on down. Okay, right. So E4, we're going to put we're just going to do right here the natural log of D4. Yep, natural log of D4. So we're just taking it right next to us. And now instead of having all these decimal numbers, now we kind of have whole numbers. Granted, they're negative because we took the natural log of a non-whole number, of a decimal number, but it's still going to be much easier for us to do this. Okay? So we have this one done. So guess what we're going to do now? We're going to do the same exact thing, lather, rinse, repeat, over onto the other tokens. Okay, so let's go back to slide number 14. Okay, and then we're going to, we have our other token sheet here. Okay, and then in label A1, we're going to put tweet. And then we're going to take our H2 to H151 on the, this time it's going to be about, it's going to be about other, not about mandrel. So we're going to do about other. So this is going to have all of our cleaned up tokens, right? And we're going to come over to H2. So we're going to copy H2 down to H151. So we're going to copy. And anybody remember what we do next? So we have the 150, and we want to make 30 sets of these. So we're going to do what? We're going to paste special, not just to 150, but we're going to go all the way down to 4501. Okay? By doing that, we're going to basically be able to put, you could have done this 30 times. You could have pasted it once and pasted it again 30 times. But by us doing paste special from A2 down to A4501, then that'll essentially paste it in there 30 times. And if you overshoot it like I did, you kind of get up and get it close. Once you get here, you just do Control Shift or Shift, and then go up to 4501. Shift and arrow up. Okay, so I have at 4501, and then you're going to paste special values, and then voila, you just pasted that, those 150, 30 times down through there. So pretty cool, right? So we could do that. Now we just paste it in there 30 times. So how's everybody doing? Good? Anybody not there? Everybody's there? Yeah, what you got, Ryan? Okay. So you're just gonna, so now you're just gonna paste special. Okay, so let's see, you gotta do the about other. Okay, so you gotta grab, so copy that. Possibly. Okay, now you're just gonna paste special. So hit cancel for a second. So if you hit paste, the down arrow click, if you go right there, that's an easier way to go. Yep, there you go. Thanks. Good. You got it, Anthony? Yep. Okay, so yeah, so you can, so we have about others. Okay, so you're gonna grab H2. You grab H2 down to 150.
Oh, no, I run the entire call. That's my point.
Okay, and then now you're gonna go.
Yeah, Japanese into complete rock turn up. Yeah. Or each rock turn up. Yeah. Yeah.
And from here, it's just shift. Okay, and then now a special. Cool. All right, how's everybody doing? Everybody's good? Everybody's there? All right, cool. So now we're going to do what we did before. So we have everything pasted in here. Going into slide 15, we're now going to put we're going to put space posits in B1. So this is going to give us our space position, space posit. Okay. And then we said for the first ones, there's no spaces, right? So we said for the first 150, no spaces because it's on the left edge. Then we're going to put 0, and you're just going to autofill down to 151. Bless you. Okay. So everybody has zeros down. So everybody put space posits in B1 and then 0 in B2 and then autofill down for zeros. Okay. So now we're going to put that formula, that magical formula in there that we used before. Okay. So it's going to be this one, this if error. So anybody remember what this guy is doing here? What's that formula doing for us? So George, what do you think? So instead of looking at the if error, look at the inside part first, and then we can go back to if error. So it's the first thing it's doing is it's going to find a space. Okay, so it's looking to find a space, and it's going to start looking for that space, starting at A52. Okay, so it's going to start looking at the space in this clump of words right here, and then it's going to start looking at that at the character of B2, which is 0 plus 1. Okay, so it's going to start, so in this case, it's going to start looking at this upside down question mark, and it's going to go over, and it's going to go what? 1, 2, 3, 4, it's going to be in the 4th spot. Okay, and then what happens, so it's going to do that 4th spot, and then so it's going to put 4, and then what happens is if it can't find this, that's when we go to the error. So if the error, if there's, so we're going to find this, but if there's an error, what we're going to do is we're going to take the length, the previous length, we're just going to add 1 to it. So we're going to go 1 space over, and that instead of it blowing up, if you don't do that, it'll just blow up on you. So just copy this formula. Okay, we're going to go into B152 and paste that in. Okay, and look at that. We come up with a what? I came up with a 4. Anybody else come up with anything different? Hopefully not. Okay, so it's a 4, right? So that was the 4th spot. So then we're going to, as we drag this down, what's going to happen is it's starting at 152, but then as we go, it's going to start repeating. It's going to go to 150, and it's going to kind of set it back to that space. So we could just simply autofill down now. Okay, so we autofill, and this is going to be where all the spaces are. So pretty cool stuff. And again, if you get towards the end where there's like not many spaces and go there, you're going to see they're just 1 over to each other. So now we have the spaces, we can do what? If we go to slide 16, we can go into C1, and we can just add token here. Okay, and then here, what we can do is we could use this formula. This one's actually going to take what we found, starting at A2, it's going to take B2 plus 1. So looks at A2, it goes to B2 plus 1, so 1 more than that. And then it's going to do B152 minus 2 minus 1. And that's going to give us our tokens. Okay, so let's grab this. And this time, if we have an error, it's actually going to put, if it can't find a space in there or a word, it's just going to put a period there for us. And that'll be like a marker. So in C2, we're going to add that formula. Okay, pretty cool stuff, man. Look at that. And just send that on down. Okay, and that tokenized all of our words, even the funky words, like that soul or whatever. It found everything for us. So pretty nutty crazy, right? Okay, then what do we do? Anybody remember? So we can manually go through each one of these and say, how many times was N in here and count all that up manually, or what? I'm sorry?
Use the count function?
Not the count function. Well, it's going to be the count function via something. So remember that pivot table? So if we take all this and copy it into a pivot table, then that pivot table will actually count all this up for us. So we can count it manually. It'd probably take us, I don't know, the rest of the day, maybe in tomorrow, or the pivot table will do it in about 5 seconds. I'm all for the pivot table. What do you guys think? Yes? All right, let's do that. All right, so let's come into, actually, I got ahead of myself. So we want to do the one thing, we want to do length too, right? So we want to grab length first before we do the pivot table. So length, and this is simply going to be equals length equals len of C2, because that's what's going to help us do our stop words. So we'll send that down. Now we can grab everything that's in C1 and D1 and go through that in the pivot table. So in slide 18, so everybody has a length. Do we not have a length? Everybody's good? All right, cool. So let's grab C1 and D1. And we can just hit Control Shift and do our down arrow, right? That takes us all the way down to the end. Or we can scroll all the way down there. It's easier. Okay? And now what? So we're going to insert, good. And we're going to do pivot table. And we're going to put that on a new sheet. And then, let's see, where to move it to. So in sheet 1, we're going to call this, instead of app token probability, we're going to call this other token probability. So other token prob. Okay. And then from here, we're going to do what? We're going to select a token and a length field. Then when we do that, it gives us that really funky, wide width. And then what? Let's shrink our width down. So we'll right click and do our column width and make that 20. All right. Okay, and then we said we wanted to do what? So we want to filter by length, but right now the value of length is currently in what? Value. So how do we get that into filter? Anybody remember? Just drag it, right? Okay, so George says drag it. Let's drag it. I like what George is thinking here. But now the other thing we want to do is we want to actually grab the tokens over here and count that. So grab another copy of token up in the fields and put that down into values. And then let's redo this into 20. Okay. All right, coolio. All right, so now we can do what? Right. Oh, just do the comma up here at the top. Right cut and comma. 20. Good. Yep, just 20. Yep, perfect. Yeah. And do count. Yeah. So just do value field settings. So that little arrow right there, and then do value field settings and do count. And then you have to do the column. Awesome. All right, cool. So everybody's sort of matches mine here, Everybody's cooking along? Cool. Awesome. And then now we have the lengths of everything, but we said we want to only filter out what? Only things that have 4 or more characters. So if we go into length up here, we can say select multiple items. We can uncheck 0, 1, 2, and 3. And click OK. And then we're left with this. And this annoying thing keeps doing the column with here. All right, cool. All right, and then now what? If we go into slide 19, we have to do add 1. So in C3, we're going to put add 1. Okay, and we're just going to simply say equals B4 plus 1, and then autofill that through. All right, and then D3, we're going to put P, instead of this time token app, we're going to put token other. So the token given as other. Okay, and then anybody remember how we're going to do that? How do we do that?
So we basically want to get to what? The probability of Friday is going to be the value of 2 divided by what? Anybody remember? So that 2 represents 2 of how many? So remember one of the, so actually we got a little bit ahead of ourselves. We want to auto sum down at the bottom. So come down here to the bottom. Okay, and we want to auto sum here. So if you click into, if you just hit your control and down arrow, you're going to get to the bottom of C810 hopefully, or at least that's where I'm at. Anybody else not at C810? Okay, and then do auto sum. So you're just going to click on the little sigma there. Okay, and 2027, how's everybody doing? Everybody's tracking? Good. All right. So probably what might be, so what I'm suggesting, Brian, you're a bit behind. So maybe you can kind of hang out with Ryan or Anthony or Alex or somebody and just do this via the video. Is that, okay. Yeah, okay. Okay. All right, cool. All right, so now how can we get, so if we remember this, it's going to be what? So we have to remember this cell C810. So now if we go up to the top, our probability is going to be what? Equal to C4 divided by what?
Divided by C8.
Divided by C810. Okay. And then if we drag this down, the next one, the C4 is going to become C5. Awesome. But C810 becomes what? C811. And we want to hold that one constant, right? We always want to be dividing by that 2027. So how do we keep that? How do we keep that locked in and then be able to drag this down autofill? Absolute values, and a shortcut to do that was we could say just throw in F4 right there. Okay, if we do F4, then that puts that in there. Okay, and then now we could send that guy down. All right. So now we have our probability. It's just simply going to be this number divided by the whole number. So that's exactly what we said. But then now, instead of multiplying all these guys together, we can just do we can take the natural log of each one of them and just add them together. And that'll give us the same thing. Okay? So in E3, let's do natural log of P. So you're just going to type that label in there, and you're going to simply say equals ln D4. Okay, and we're going to send that down. All right, so how's everybody doing? Everybody's tracking? George, you're good?
Yeah. How many decimals?
It doesn't matter. Yeah, it doesn't matter. Anthony, you're tracking? I'm sorry?
I don't have the absolute value.
You have the absolute value? Okay, yeah, so just go in and do that and then autofill it down. So you go back into the. Okay, so we said, so we're going to equal to what? So that's going to be equal to, let's make sure, it was 810, that was where you got to. So you got 1222 instead of 1227. Somehow you're off one, but we'll just go with that. Equals, it's just too hard to find it. So equals C4 divided by, and then what was that, 810, C810? And then you're going to put the absolute reference on that thing. Would you guys come up with your numbers for the count?
2027.
2027. Okay, so you're off. Come up with that. All right, hold on a second. Let me pause this real quick. Let's move on to slide 20. Okay, so now the cool thing is we have our trained model. So we talked about this being supervised or unsupervised. What do you guys think? Supervised or unsupervised? Supervised, because we did what? We actually took 150 tweets, we broke them down, so we're training our model now. So now that we have our model trained, now we have 20 test tweets that we want to go analyze and see how well we did. Okay, so we have 20 test tweets, and we actually know if these were the application signal or whether it's noise, the other. Okay, so now that we have that out.
Your E4 switched to
My what?
your.
Oh, thank you. Thank you. Okay, so let's go into the test tweet sheet. If we look again, we have 10 that are applications that we know, and then we have 10. Oh, there's our shit too. Remember, we're trying to find where shit was at in our thing. So there it is. Holy shit, it's here. So that's, we found it. So we wondered how that got in there. So there it is. All right, and then so we know that these top 10 are the application and the bottom. So now we're essentially going to do what we're essentially doing now is saying, all right, we have our model. Let's see how good it actually really is. Okay. So we're going to clean up our data, but just like we did before. But the cool thing about this is that we can just copy our cells. We can just copy the cells in B1 to H21 and either other tokens or about, or let me see which one. You can just do, I'm sorry, about other. So in this one, what we can do is you can just grab, you can come up and grab from B1. And I'm just going to make this column smaller. Okay, so you're just going to grab from B1 all the way over to H21. Okay. Now this time we're actually going to paste, we're going to actually paste the formula, not the values, but we're going to paste the formulas. Because if we do this, what Excel is going to be smart enough to do is grab all those formulas like we did lower and everything else. It's going to bring all that over, and it's just going to apply it to that data, and we're not going to have to retype it out. So if we go into test tweets, and if we go into D1 and just hit paste, not paste special, but just paste, so Control V, okay, that's pretty cool. Now we can just auto, and then auto fill down. Wait, actually, don't do that. Now grab from each, go over from D2 to H2, and now autofill that down. Okay. Yep. Yeah. So what we did, so here is our test tweet right here,
And what we want to do is we want to clean up this data just like we did before. So lower and a comma and everything else we did. We can do all that, but we already did it once. So by coming over into About Other or About App, we can actually grab all that. Instead of doing paste values, we're just going to paste. And if we do, you're going to apply, it's going to be the same formulas, and you're just going to be able to do that. Okay?
Okay, how's everybody doing? So how's everybody doing? Good, bad?
Where did you paste the formula?
So paste the formula. So you're gonna, okay, so here you guys, I'll walk through it here again. So if everybody got lost, I'm walking through it. Either go to About Other or to About App. And then you're gonna grab from B1 over to H20, or B1 over to H2. So this is the mismark. It should have been copy B1 to H2, not H21. Okay. Or actually, no, I'm sorry. You could have, I'm sorry. Yeah, we could have did that. Sorry. I messed everybody up by doing autofill. So do this. If you got lost on this, grab from B1 down to H21. So if you just grab that and you copy, and if you go over to test tweets, just go over to D1 and hit paste. And not paste values, paste special, just paste values. Okay, and if you do that, then if you look at the formulas, that formula is just grabbing lower of C2. So it copies the formula and it just does the reference. So on the other sheet, it was like 1 to the left. In this case, the 1 to the left of D2 is going to be C2. So it's pretty cool that it grabbed all that and kept everything in there for us to make it quick, fast, working smart, not hard. Okay, so everybody's tracking. Anybody not tracking? Everybody's good? Brian, Anthony, George, Alex, everybody's good. All right, cool. All right, awesome. So now if you go into 21, so I actually kind of made it convenient for you guys. So I actually hid a sheet in there that we're going to use. So like kind of like the little Easter eggs that Microsoft used to put in there, but nobody laughs at hidden software anymore. If you right-click the table down here, you can click Unhide, and then you'll see Test Predictions and go unhide that. So I put that all in there and formatted up nice and pretty for us. So just to save us a little bit of time. Okay, so everybody has it? Test predictions? All right, so now what we're going to do is we're going to copy the column J2 to J21 from test tweets and paste as values. So this time you are going to paste special as values. So go into J2 to J21. We're going to copy, go into test predictions, and we're going to paste in D2 to D21. Don't paste in C2 to C21, but we're going to paste special into D2. So you just simply just hit paste special, and I'll dump it all in there. So now we have everything all cleaned up. Okay, everybody's tracking, everybody's good. Awesome. All right, so this time what we're going to do is we're going to tokenize, but instead of tokenizing all the words, we have all those guys. What we're going to do this time is we're going to tokenize by looking at spaces. So we're going to do text to columns, and that's going to be a lot easier for us. So we go into slide 22. What we want to do is we're going to select D2 to D21. Then we're going to come up here into the data tab at the top. And then if you come into data tools, you're going to see text to columns. So instead of doing like the find and the mid, and this is actually a lot easier for us. And we're going to have the check mark that says delimited, because we're going to delimit based on spaces. So once you get to this wizard, you're going to hit next. Then you could do tab and do space. Actually, you could just do, you can unclick tab if you want to, you could just do space. And we want to have the checkbox that says treat consecutive delimiters as 1. And the text qualifier as none. So do that, just say none down there. And we're going to press the finish button. And it's going to go tokenize everything for us.
So now it just tokenized everything based on spaces. So I just wiped everything over there. Cool stuff, man, isn't it? I love watching you guys' smiles on your faces. Pretty, I mean, this is cool crap.
All right, cool. So now we're tokenized. This is good. But so this is our test tweet. So guess what you have to do now?
Now we have to go match up the word just for app based on our training model. So we have 2 ways we can do this. One way is we can go in and we can look for the word just in all 800 rows and do that for all these words in here. But I'm a fan of VLOOKUP. We can use VLOOKUP. You go to that vertical column and look at those guys, just match it up and give us the probability. What do you guys think? That sounds a little bit easier? Everybody a fan for that? All right, cool. All right, so if we look at this, let's go talk about this VLOOKUP formula for a second. So I'm going to expand this out. It's going to be easier to see this guy here. So if we look, actually, you guys can look at your slides, but or look at the Excel when I'm doing this. But our base formula is going to be VLOOKUP. We're going to look up the value in D2. And for the app tokens, that's going to be based on going from A4 to E826. Actually, let me do what I had before. So if we look at this, we're looking up the word just. So what this formula is going to say is we're going to look up the word just. Okay. So that's going to be in D2. And then we're going to look at our app token probability. So if we come over here, we look at app token probability. And in this case, we're going to look at A4 down to A26. And then we're going to make sure that we put that in an absolute value, or I'm sorry, an absolute reference. If we don't, as we drag it down, then A4 is going to become A5, E826 will become 827, and we always want to keep those same values, okay? And then we want to look in column 5. So remember the VLOOKUP? We're basically looking at this whole chart. We're looking for the word just. It's somewhere in here possibly. And if it is, we're going to go into column 1, 2, 3, 4, 5. And it's going to return a probability for us, okay? So that's kind of our base formula that we're looking at. And we're using false to make sure it's an exact match. If we go on to slide 25, we have to account for the rare words and the stop words. So to do that, if it finds a rare word, if it basically can't find that word, what we're going to do is say is not applicable. So that's is an A. And then we're going to say do the natural log of 1, because if it's a rare word, we said we don't want to do it but divide by 0. If we do it, it's going to be 0. We always want to make sure it's at least 1. So we're just going to divide by 1 by the app token probability and see 827, whatever that guy is in there. And actually, it might need to be 827. Let me see. Yeah, so we do that. That's going to have to be 8. Oh, never mind. It's right, I think. Yeah, it's 827. All right, so I did do it right. All right, so then that's gonna count for our rare words, and then we're gonna say for our stop words, we're gonna say, hey, if it's less than 3, we're just gonna give it a 0. So when you put all that together, let's look at this heinous formula, because it is heinous.
but it's not too bad to look at. So let's look at, expand this guy out. And this is probably going to be the longest formula you guys ever looked at. But here's our formula. Okay? Look at this monster. Okay? So let's break this down. Look at this. So what this is saying is, hey, if the length is less than or equal to 3, then we're going to say 0. So if the length is less than 3, 0. Else, if it's false, then we're going to do this if. So we're going to say, hey, if it's is not applicable, then we're going to do the second part here. Or if it's not as applicable, we're going to, if it is applicable, we're going to do the VLOOKUP, okay, right there. And then if it's not applicable, meaning that it's a rare word, we're going to do the natural log of everything we did before, but instead of, because it's not there, we actually have to do 1, because it's going to be the single one, and then divide that by that same count, so it's equal to everything. And then we're going to put that, then return that value, okay? So, but if it is applicable, then we're going to do the VLOOKUP. So, big, long, heinous formula. So just copy this guy in D25. That'll be kind of your homework. If you guys could go look at this offline, I want to spend forever trying to analyze this guy. So you're going to copy this formula here. And then we're going to go over into test predictions. Okay, and then on D25, we're going to put this guy in there. So we're going to paste that guy in. Okay, and we found the word. We found the word because if not, it would be the natural log of 1. It's going to be less than that. So it actually was able to go in, find that word just, and then come over to the 5th column and enter that value in there for us. If it was, so if it didn't, if that length was less than 3, it would basically say a 0. If it couldn't find that, essentially it's a stop word. It would have taken the natural log of 1 divided by the count of 827 and then return that. All right? So this is kind of cool stuff. So take this and we're going to auto-fill this down to D44. All right. And then we're going to autofill this guy across. And it should take it over to AI is where we start running out of words. So I'm going to make mine a little bit smaller here. Okay, and then let's just, so we're basically going to expand this over until we run out of words. So if you just autofill, grab down this corner and autofill over. So if you look up here, here's the last column where we found a word. So I think, so let's go back, let's repeat that for a second. So the first thing we're gonna do is once you get that formula into D25, you got no value? Oh, because you had the autofill and everything else.
Oh.
Congrats. Okay, so now you're going to autofill down to D44. Okay, once you get autofill to D44, then you're basically going to autofill across till you start running out of words. Okay, so what this is doing is it's applying, this is applying the app token model to all these tweets. Okay, guess what we're going to do next? So we just applied the app token probability to all these words. What do you think you want to do next? Anybody have any thoughts?
So we always want to be fair in the sandbox. So we want to do what?
Find other token probability.
Apply the other token model to this, right? Good, Alex. So let's go into D48, and then you're going to copy this formula, this other heinous formula. And essentially, this is going to do the same thing, but instead of the app token, it's going to use other token. And then it's set up so it goes to 809, and then all those values should be work. Anthony's, yours might blow up here. All right, so D48, we're going to put this formula in. Okay. Oh, wait, I put mine in the wrong one. Okay. And then you're going to drag this down to D67. All right. And then now we're going to drag this across over to AI, column AI, because that's where our words stopped. We come over here, over to AI. Okay. And then here's going to be all of our words and probabilities. Okay, how did everyone do? Everybody got it? Did yours work, Anthony? All right, cool. Awesome. Everybody's tracking, everybody's good. Awesome. All right, cool. So now we basically we've applied the app token model to these test tweets, and then we just applied the other token probability of these tweets. And what we can do is the one that has the higher count, what we're gonna do is we're now gonna total all these guys up. So if we go into 26, so in C24, we're gonna put the sum of conditional COND prob. This is gonna be the sum of conditional probability. And guess what we're gonna do now? We're just gonna auto sum and get the rows. Okay, so if you hit the auto sum, if you go into home auto sum, it should grab, actually you're gonna have to, since it's not vertical, you're gonna have to go over D25 over to AI25. Okay, and we get that number. Then we can simply just autofill or just drag this number down to C67. But where we had that gap in between those numbers, C45 to C47, just delete those. You can just highlight those guys and delete. Okay, so now what we have is we have all the 20 rows. We've looked up all the probabilities for the individual word. We summed them up. And then we said way back on slide 8 or so, we said, hey, if the value for application is higher than the value for other, then that should be a tweet for mandrel, the signal. If the value is higher for other than it is for mandrel, then that should be noise. Okay, so that's kind of cool. So going on to slide 27, in C2, right here, we could do this formula, and this is going to be exactly what I just said. If C25 is bigger than C48, so essentially you're going to compare C25 to its counterpart of C48, whichever one, if that's bigger, if C25 is bigger than C48, you're going to type the word app. If it's false, it's going to be other, meaning that the other person's in there. Okay, so we're going to put this in here and then autofill down. So grab this formula. We're going to go into C2. Okay, look at that, app. And what was it? App. Okay, go autofill that down. Let's see what we come up with. This is insane, guys. This is insane. We took that model. We got all the apps 100% right on our test tweets. We had one that we said, one other, we said it was app. And we said we want to be conservative because we said before, when we set up our model, we said typically in real life, 20% of the mandrills applied to them and 80% applied to other. But we did our model, we set it up for 50-50, right? Because we did it for 50-50, it's going to err towards false positives. You would rather say that's an app and later find out, oh, it's trash, dump it, versus missing something. Maybe that's $1 million deal you would have missed. So if you look at this and think about this, we took 150 tweets, we ripped them out, trained them, took 150 test tweets, did the token probability, did the lookups, and applied that to this model. And with 10 applications that were real, we got 100% of those right. That's insane, guys. That's like going to your company, and if you had 1,000 tweets, and let's say 20% are yours, you would grab those 200 and say, here you go. Give that to the marketing department and let them go at it. And throw the other 800 away. Maybe you would have pulled up maybe like 210. So you gave them 210. You threw 10 away. So instead of your marketing department looking at 1,000, they're looking at 200. So if they were doing that, if you're the CEO, you love that because you could have said, let's say you had 5 people doing tweets, you could say what? If you had 5 people and each one are probably doing 200 tweets a piece, what can you do? What can you do, CEO? So you guys aren't thinking, once you get the taste of like a good fat bonus, like at IBM, I get big, fat, juicy, quarterly bonuses. Then you start thinking, like that always drives behavior. So if you're at IBM, if I'm at IBM, I'm like, oh my gosh, if I could do this, I can go sell to the employer like, hey, you know those 5 people? Guess how many you need now? 1. So you can either repurpose those 4 or what? Possibly kick them to the street, which is horrible. You threw people out on the street, but you know what happened? Your cost went way down, your revenue stayed the same, so your profit just went way up. So if you're the CEO, that means what? Bonus time! That's the way of the world. So you have to be the person that can come up with this model, or you've got to be that one of the 5 that keeps her job. So you pick whichever one you want. Okay? Pretty insane stuff. How'd your data come out, Anthony? On the apps or on the others?
Apps.
So apps, you had 4 that were others.
But we came out as apps.
What now?
The predictions that were wrong, they predict other, but outside.
Oh, let me see. So that's okay, but you got all the apps? Oh, no. Oh, so you missed them. Okay. So somehow your app data is off. So if you wanted to, you can go back.
Or try mess up the database because it gave me a bunch of slides too.
Oh, did it? Okay. Well, yeah, if you go back through, it's probably that your others are good, and it's probably that your apps are off. So if you want to go back and go take a look at that, that's fine. So pretty crazy stuff, right? So let's go take a look at this next slide. All right, so homework. Of the 10 MailChimp ads, how many did the model get correct? What do you guys think? Of the 10, how many did it get correct? All 10, 100%. Okay. The Mandrill tweets, how many did it get correct? 9 out of 10, 90%. Still not bad. But the good news is that it erred on giving you a false positive. So you'd want to have that false positive and throw that out versus missing one above. Okay. So now how can a business now use these tools to increase revenue and or decrease costs? Okay, pretty cool stuff, right? All right, so in wrap up, so a lot of times programmers love naive Bayes. So everything we did, it's really easy to code this and do them in for loops. If you're doing it in Python or something like that, works really great with words. realistically, instead of using individual words, you get better accuracy if you start looking for phrases, but that's a whole can of worms. It's really hard to start doing that. Requires a lot more training and a lot more rare words then, okay? But the cool thing is 98 Bayes, I mean, this is pretty straightforward to use. I mean, you basically just got the words, tokenized them, did the probability, did VLOOKUP, looked them up, and bang, voila. All right? Cool beans, man. All right, so we have about like 9 minutes left. So perhaps we can convince Doug maybe to come up and share a little bit about his day job as an analyst and where he sees all this going. So Doug?
Yeah, absolutely.
So yeah, this was good stuff, guys. What I do on a day-to-day basis is I work for a company called Health Integrity. And what that is all you guys that have had jobs and you see money come out of your paycheck that goes into a Social Security or Medicare fund. What Health Integrity does is we're kind of the watchdogs for Medicare. So what we do is we look over Medicare and we look for fraud, waste, and abuse. And the way that we do that is through data analytics, like you guys are learning right here. So on my team, we have some subject matter experts. Those could be pharmacists, medical directors. Then we have a big data analyst team, and then we have investigators. So what we do is we run predictive models and we do analysis on all of this data that comes in. Every time you guys go to CVS and you fill a prescription, it goes into prescription drug event records. So there's a database of billions of records that we do analysis on, and we pull information out, basically looking for doctors, pharmacies, beneficiaries, people that are getting drugs that are trying to defraud the government, right? They're trying to get money from the government that's not theirs. And what we're doing is we're trying to catch them, hopefully beforehand, but sometimes reactively getting this and recouping the money for the government. So we're talking millions and millions of dollars every year that there's pharmacies or doctors that are stealing from the government. And what we do is we use analysis, in particular myself, I work closely with the investigators, and I will come up with different models or different things that we look at to try to find these bad doctors. And I kind of put a case together, present it to my investigators build that case, then it goes to the FBI. All right, so what we do is we work closely with law enforcement, closely with the government. What we're trying to do through data analytics is get these bad doctors out of the system, get the money back for the government, and it's a win-win for everybody. So just for example, the thing I'm working on right now is we're calling it phantom pharmacies. And what that means is through data, we're able to figure out, are these pharmacies really existing, or are they just kind of on paper and they're stealing money from the government, right? So you'd be surprised. I have all these pharmacies right now that I'm looking at before I came here today that billed Medicare for $1 million, $2 million in the last 18 months, and they only have 5 beneficiaries. And those 5 beneficiaries are on a compromised number database, meaning that their Social Security numbers were probably lifted and they're not good Social Security numbers. So they're doing nothing but just stealing information. I mean, just stealing money from the government. They don't even have a building. So what I do is I go through, I run my analysis. We come up with all these. I'm going to come up with probably 50 different pharmacies that my investigators need to look at more in depth. Another thing I uncovered through these analytics is New Jersey has about 20 pharmacies where 100% of their beneficiaries are compromised numbers, and I don't think their buildings exist. So using Google Maps and kind of intertwining that with my data analytics is this doesn't exist at all, and there's 20, and they might be owned by the same type of people. So that could turn out to be a huge bust. And if you guys ever see anything in the news or anything, Medicare bust or Medicare, that usually initiates with us, right? So there was someone just busted recently for opioids. He's going to jail for 30 years because he was overprescribing opioids or selling. He was billing Medicare overly for opioid type thing. That's a big kind of a hot topic right now is opioids. And so that all started with us going through that process. Does that kind of make sense to you guys what that is? So I mean, we hear Medicare a lot, and then we're all paying into it. So it's a really hot button issue with the government because it's taxpayer money, and they want to make sure it's being protected. And they're heavily invested in the data analysts for that. Another part of what we do is we do a lot of predictive models. We have a platform called Plato that we roll out to health plans. And health plans are Aetna, Cigna, Humana. If you have health insurance, that's a health plan. And what we roll this platform out to them using our predictive models. they can kind of look at their patients or the prescribers in their system. They punch them into our system, and we give them kind of a risk analysis. This guy has a high probability of that they're stealing from you right now. Your investigator is going to take a deeper look at him. So that's kind of, you know, it's the business stuff is obviously where a lot of this analytics is going and all that, but this is kind of a different platform of how the analytics is being used to kind of save our government money and really save us money, because eventually we're going to want that Social Security money. We're going to want, you know, we're going to want that Medicare when we're older. So trying to protect that a little bit.
So cool stuff.
Yeah,
So
interesting.
what do you think about these guys in this class, and what that would mean to, if you're interviewing a new worker? It's like, hey, I was in this data analytics course versus
Right.
not.
Well, I think the big thing is, I think everyone's using analytics on some degree, right? Everything analytics is kind of everywhere. So if you understand how those analytics work, understand where it's coming from, you can then explain that to your employer. Because that's the big thing is, we have a lot of data scientists that can't really, there's a little missing connection there of being able to explain to the upper management and actually use this analytics. Like, you need to have a strategy to use all the data that's out there so that you can get the most out of it, if that makes sense, right? So you want to, you know, a lot of companies now, because it's been big data is they have tons and tons of data, but they might not necessarily have a strategy involved. And that's where coming in with this type of knowledge, you know how this data works and you know what to get out of the data. That's very attractive to employers. I was talking to Rick earlier. I'm always looking at different odd job openings and things, and data analytics is everywhere, depending on what, you know, I mean, even in roles you might not even think it would be a part for, they're asking for data analytics. Like, that's a preferred thing, because it's just so heavily involved. I mean, everything we're doing is data analytics. Like, especially this big data, like if you guys have, you know, Wells Fargo, whatever, and couple transactions are off, they're using data analytics to say, I think your card's been stolen. We're going to shut your card down, which, you know, that's cool. Right? I mean, that's an amazing thing. It's happened to me a couple of times. So it makes me think, am I spending like someone that's had like I stole my credit card? Am I spending that way? But it's awesome that they can do that just based on their predictive analytics and their like kind of their deep learning. They can say, this doesn't look like we're going to shut your card down. You got to call it. Like, it's everywhere. So the knowledge of how it works is so valuable. It's going to be so valuable to an employee anywhere you go.
How long have you been doing this?
I've been doing this. This is my 4th year with this company. I started out, I have a degree in management information systems. I came out, I went into the financial industry, so I got a CPA. And so I was doing accounting and financial statements. And then I had, my buddy's been doing this since we graduated. He's like, your skill set, technology, kind of policy stuff, you need to come help me on this stuff. And I love it. It's great. It's so much more interesting than doing somebody's tax return or filing financial statements. And you feel good about it, right? You feel good if you worked on something. For me, you work on something and then you're talking to the FBI about it and they're going to go bust people. I mean, that's pretty cool. I mean, it's close as you can be to being an agent without, you know, being out in the field. It's a pretty good thing.
Is this like the first class like in here for data analytics, or did you go to school?
I went to, I just got a master's degree, and that was in information systems, but it was emphasized or concentration in data analytics, business analytics specifically. So a lot of what I use on a day-to-day basis was kind of similar to that class. I use SQL a lot, you know, for the big data queries and everything. Then we get it down and do a lot. I actually do a lot in Excel as well. Yeah.
Awesome. Very good. Awesome. All right, cool. All right, so let me stop recording here. But yeah, so thank you, Doug. Awesome. Yay. Yeah, thanks for coming in
Thanks for having me.
yeah. So I'm guys, this is